Good morning, ladies. It's Mr. O'Sullivan. Today we're going to be looking at lesson 4-9, the addition and the subtraction postulate. So what we're going to be looking at today is we're going to be looking at how we can add side lengths together and angle measures, and how we can also subtract them to make conclusions when we're marking our image. So today's learning target is I can apply my knowledge of geometric terms by marking an image and forming a conclusion. Whenever we're learning about new postulates, this is going to be our go-to learning target. We want to know by the end of the lesson how we can apply our knowledge of these terms to not only just mark an image, but to form a conclusion. So if you look, I'm not giving you the conclusions I want you to make. I'm giving you all the givens. So I'm giving you all the information you need, and what we need to do together is we need to make our conclusions. So let's look at these examples, and we're going to take them nice and slow. We're going to take our time on Zoom, so in case you wanted to just watch this YouTube video for extra help, go ahead. So in our first situation, we have AB equals DE and BC equals EF. The first thing I want us to do is we're going to mark our images with that conclusion. I mean, not that conclusion, that given information. So I can say that AB is congruent to DE and BC is congruent to EF. If you look, I have one tick mark on AB and two tick marks on BC. I have one tick mark on DE and I have two tick marks on EF. So what I can do is I can actually add AB and BC together to make AC. And I can add DE and DF together to make DF. So my first statement is going to be AB plus BC is equal to, or congruent to, segment AC. So I'm basically doing part plus part is equal to my whole. So you always need to make sure that you do part plus part is equal to your whole. I can also combine statements to make just one statement. I can say DE plus EF is congruent to DF. And what that's going to tell me is my reasoning for this is addition. I'm adding my segments together. Now, what you can do is, since I have one tick mark plus two tick marks and one plus tick, I can say that AC is congruent to DF. But my reasoning isn't going to be addition, it's going to be substitution. Because you're substituting what you just concluded. Okay? Now let's go on to our next example. In this example, I have AB is equal to CD, so I'm going to mark that with a tick mark. And if I look, I actually think I can make a few conclusions. What I want to show is that this segment right here, AC, is congruent to BD. And I can show that because if you look, where I have my highlighter, there's some overlap at BC. Whenever you have overlap, you have a reflexive. So I can say BC is congruent to BC. And my reasoning will be reflexive. Now I'll do what I just did before. I'm going to add my segments together to make a whole segment. So I will have AB plus BC is congruent to AC, because part plus part is equal to your whole, so AB and BC make AC. And now I can do BC plus CD is equal to BD. CD, not BD, sorry. And that's congruent to BD. And that will be addition. Now my final step is I can say AC is congruent to BD by substitution. And that's your final answer. Now let's look at our next example where we have AE is congruent to CF. So I have AE congruent to CF, so I mark my image. And if I look, I can actually say that AF is congruent to EC. And there's overlap at EF. So the first thing I can do is I can say EF is congruent to EF by reflexive. Then what I can do is I can do my addition. So I can do AE plus EF is congruent to AF. And now I can break apart EF and I can put together EF and FC to make EC. So EF plus FC congruent to EC. And that's going to be an addition. And then last but not least, I can say my holes are congruent to each other. So I can say AF congruent to CE by substitution. Let's go on to number 4. The measure of angle ABD is congruent to the measure of angle EFH, so I'm going to mark it. So ABD is right here. I'm going to do one semicircle, and that's congruent to EFH. I also know, I'm not sure why it just went up. I also know that angle DBC is congruent to angle HFG. So if I look, I have one semicircle and one semicircle, and then two semicircles and two semicircles. So I can eventually say that those whole angles are congruent to each other. So we do our addition, but this time we don't do it with segments, we do it with angles. I can say angle ABD plus angle DBC is equal to my whole angle. So number 1, I can say angle ABD plus angle DBC is congruent to my whole angle of angle ABC. And I can do the same thing with this visual to the right. I can say angle EFH plus angle HFG is congruent to my whole of angle EFG. And I did that by going from small to big to make addition. So this will be my addition step. Step 2, I can now say that both of those angles are congruent by substitution. So I can say angle ABC is congruent to angle EFG by substitution. Now let's go to our next example. I have AC congruent to DF. This is not going to be an addition example. Just a heads up, this will not be an addition example. So I have AC congruent to DF, so I have a hole is congruent to a hole. And I have BC is congruent to EF. I can show that A, B, and DE are congruent, but it's going to require a little work. So instead of using addition, what we're going to do is we're going to be doing subtraction. So if you're starting with a whole and you want to get down to a part, you're going to take away a part from your whole. So to approach this question, you're going to do AC minus BC, and that's congruent to AB. And then you're going to take your second whole of DF and take away EF. And that's going to give you DE. Now that you took away two segments that are congruent to each other, you can now say that AB and DE are congruent to each other by substitution. So reason 1 is going to be subtraction. Reason 2, substitution. Let's go on to our next example. In this visual, I have AC is congruent to BD, so I can actually go a little backwards now, so I do my highlighting, just like this. And if you look, there's some overlap. I have an overlap at BC. So the first thing I'm going to do is I'm going to say BC is congruent to BC by reflexive. Whenever you have a reflexive, you have to mention it because you need to make sure that your proof is strong. Now, I have a part and a part. So I can break apart AC to be AB. Well, I can do AC minus BC to get my AB, because I can show that this segment and this segment are congruent to each other. So what I'm going to do is I'm going to do AC minus BC. And that's congruent to AB. And then I'm going to do BD minus BC. And that's congruent to DC, or CD. That is my subtraction step. Now what you can say is that AB and CD are congruent to each other by substitution. Let's go on to our next example. In number 7, I have AF congruent to EC, so I have a hole congruent to a hole, and if you look, there's overlap right at EF, so I can say EF congruent to EF reflexive. Now, I can show that AE and FC are congruent. And I can do that by basically taking away EF from my hole and EF from my other hole. So when I take away EF, that's my subtraction. So I can say AF minus EF is congruent to AE and I can say that EC minus EF is congruent to FC. And that would be a subtraction, because you're going from big to small. You can now say that the two segments on the right are equal to each other by substitution. Two more examples. In this example, I have angle ABC is equal to angle EFG, so I have a hole is equal to a hole, and then I have angle DBC, so a part, congruent to angle HFG, which is another part. So I can actually show that this angle and this angle are congruent to each other by using subtraction. So let's do it. I can do my whole minus my part, so I can do angle ABC minus angle DBC, and that will give me angle ABD. I can do the exact same thing on the right, where I can do angle EFG, so my whole minus my part of angle HFG, which will give me angle EFH. That would be a subtraction. Now what I can do is I can say angle ABD and angle EFH are congruent by substitution. Perfect. One more example. Number 9, I have angle ABE. So if I look, that's a hole right here. Angle ABE is congruent to angle CBD. And if you look, you have a reflexive where there's overlap. I have a reflexive right here. So that's angle DBE. So I can do angle DBE congruent to angle DBE, reflexive. Now I can do my subtraction, so I can do my hole minus my reflexive. So my hole would be angle ABE minus angle DBE, and that would give me this angle right here. So angle ABD. Now I do my subtraction on the other. So I do my hole, which is angle CBD, minus my reflexive of angle DBE, and that's congruent to my piece of angle CBE. And this is a subtraction. Now what I can do is I can do my substitution and say that angle ABD and angle CBE are congruent to each other. And that's it. So if you have any questions, email myself or Miss Daniel. Have a great day, ladies.